does time be visible?
This is only my third flat Earth tangent kind of debate, or adjacent rather. Um, I typically will do like evolution versus creation debates, or yeah, mostly things I would consider pseudoscience or pseudo history. I do debates on a lot of different topics on my channel, but I'm interested in all things science and history.
Awesome. No, that's interesting. I just subscribed to U2 and I sent you a link to everybody to subscribe if you guys want to. So yeah, that's awesome. Let's get him over 1,000 subscribers, guys, so he can start doing his own live streaming and stuff as well. I'm sure he would love to do that.
Hey, well, I appreciate that a lot, Flatzoid. Thanks for
Because
starting the debate off on a good footing.
I know it's always difficult. That first 1,000 subscribers is a is a real grind, to put
Yeah.
it. Okay, so
It's
you
been a fun one though. I've done debates with Kent Hovind. I did a debate with Iron Horse. You probably know him.
I've
He's
seen.
a
I
fellow
think I've
flat
seen you
earther.
on Modern Day Debates already.
I've been on Modern Day
Yeah.
Debates twice. Once for discussing the Big Bang, and then the second time for the flat Earth. Both 2v2 debates.
Awesome. Yeah, I haven't been on Modern Day Debates for a while because it's always hits me like at 1 or 2 in the morning. So
Yeah,
it's a bit
the
hectic
time zone
time.
difference was killer here. Yeah.
Yeah. Okay, so I know we didn't really set up a structure or anything. So you can start it off and what your thoughts on, and we can take it from there, I guess.
Sure. Yeah. And just FYI, I'm really not a very structured person. I think that we can have, a relatively polite, cordial, and mature conversation between two adults here. I don't think we need a whole lot of crosstalk just to have a conversation about, gravity. What is it? How do we know it's a thing? Um, so I guess I did have kind of three things to go off of here, but the main question that I was responding to, right, was in your recent exchange with MC Toon that got a little bit heated, where you were continually asking this question of what is gravity. So I thought that we could maybe start on that point. That's probably a good point to start off on a gravity debate, right?
100%. Yeah, that'd be great.
Sweet. So I want to clarify here because there's two meanings to what gravity is, depending on if you're talking about classical mechanics, aka Newtonian mechanics, or if you're talking about Einsteinian general relativity. So I think that the distinction there is where a lot of the confusion is coming into play, where you're saying, does gravity cause gravity because F equals ma? And this whole thing would be kind of a confusion within Newtonian mechanics. And then there's a difference with Einsteinian general relativity. So just if I can define it within both regimes, just so we're on the same page, I think you know this, but I'll just put it out there for everyone so we're on the same page here. In Newtonian mechanics, gravity is an attractive force between masses. In Einsteinian general relativity, gravity is the curvature of space-time that results from mass energy. So in the general relativity lens, the actual force that is the gravity in Newtonian mechanics is a pseudo force. That doesn't mean you can't measure it. You can still measure it in newtons, just like you can measure other pseudo forces like centripetal force or centrifugal force. You can still measure those in experiments with units of force, newtons, but there are technically pseudo forces which depend on your frame of reference. So it's the same case with gravity under the general relativity regime. So I assume that most of this conversation will be talking about gravity being the curvature of space-time in general relativity.
Yeah, sorry,
Sorry if
my
I ended
daughter.
that at a
Sorry, my
confusing
daughter.
point.
Okay, from Mama Soppy. Sorry, my daughter's asked for.
Yeah, no worries. But that was basically was going to be my point, was that I think we could talk about how we know that gravity is curvature of space-time, and I kind of brought three main lines of evidence to support that claim.
Okay, yeah, because you know what I'm going to ask straight away. Can you back this claim up?
Yeah. So the three things that I would point to, and I think that they're all super interesting, but just in order of what I find the most interesting, gravity waves, gravitational redshift, and gravitational lensing would be the three things I would immediately point to substantiate the claim that gravity is space-time curvature. And if you want, when you say that gravity causes gravity, right? Just so that we can clarify that, what I would consider to be a misunderstanding, but I'll give you a little bit of credit because I think you could kind of say that Einsteinian gravity causes Newtonian gravity, because obviously Newtonian gravity, which is that pseudo force, that the acceleration and the force are both caused by the curvature of space-time. So what we would call gravity under a Newtonian regime would be caused by the curvature of space-time, which is gravity in an Einsteinian regime. So I don't think you're wrong to say that Einsteinian gravity causes Newtonian gravity. It's just not the way that you would be learning it about it in a physics textbook. But I think in a technical sense, you could get away with saying something like that.
Okay, yeah, because that's the thing. That's what I was saying. So you guys are claiming gravity causes gravity, and if you're saying, okay, it's the mathematical construct in the fourth dimension causing a physical force to appear, you don't see the problem. Because let's, for instance, say
Pause for a second right there. I don't mean to cut you off, but just right there with how you summarize that, it's not necessarily in the fourth dimension, right? The fourth dimension would just be time. So it's within space-time, which is four-dimensional. It is not the fourth dimension. It's just a four-dimensional manifold.
Yeah, but we are three-dimensional beings, so we aren't able to observe in the fourth dimension.
No, we are four-dimensional because we exist within space-time, which has four dimensions.
You see, that's where I disagree with you.
We are three-dimensional in terms of spatial dimensions. But in terms of all dimensions, we're four-dimensional because of time.
But time's a man-made construct. Time doesn't exist.
It really is not insofar as the symmetries of Lorentz transformations are concerned, which is why space-time is just one thing and not space and time. It's because of the symmetries during Lorentz transformations within like Minkowski space. It's very mathematical. But there is a reason why time is not simply a man-made construct. Now, when you're talking about the measurements of time... Okay, sorry.
How would you go to providing evidence that time is not just mathematical?
Time is not just... Because we can measure the differences in time dilation due to gravity. That's what gravitational redshift is. It's a direct observation of the curvature of space-time from gravity.
No, that's what I'm asking. You're saying time is not just a concept, so I'm asking you, what would you be to base on actual showing time is physical? That's not just a concept, because
time
would physically have
due to gravity. That demonstrates that it's not just a construct.
But that's again just you begging the question. It's due to gravity. You're saying I see time dilation, therefore gravity. That's just circular reasoning.
I failed to... Could you extrapolate on why you think that that's circular reasoning? Where is the circularity involved?
I just explained it. Time dilation, therefore gravity. You understand? Because that's exactly what you're saying. You're saying because we see time dilation, therefore time is bending thanks to gravity. So it's circular reasoning.
So gravitational redshift, right? We have a one-dimensional lattice of molecular clocks, right? Each one is beating at the same time, pulsing at the exact same rate. When you align them all so that they're all at the equal altitude, they all go in unison at the same rate. But when you rotate it just to be vertical along gravity, you see that the rates change now as a result of their altitude. So this is demonstrating that gravity is changing the time dilation effects.
Could it be density that's changing it and not gravity?
It could not, no.
Why not?
Because the density has not changed. When you rotate it this way or this way, the relative density hasn't changed at all because it's within a vacuum chamber.
But what happens to the center of mass when you turn something vertical?
It doesn't change. It's still in the center of that one-dimensional lattice.
No, remember, if you got two timepieces together like this, there's the center of mass in the one, here's the center of mass in the other. As soon as you're turning it up, the center of mass is now the force. It's forcing itself vertically down now, not...
So, here you go. The center of mass is right here at the point where my fingers meet. If I turn my fingers right here, the center of mass is still that point where my fingers meet.
Yeah, but the vector...
It hasn't changed.
But the vector has changed.
But that doesn't change the density.
The density... the The density
If
is
you'd
what
like,
gives the
I'll
vector.
actually
The
I'll provide
density,
you a source for this.
the density is what gives the vector, and this can be scientifically validated.
The density is what gives. No, I don't think that is the case, sir. Because it's in a vacuum, so the relative density is equal in all directions.
Yes, vacuum. Why do you think they do it in a vacuum?
Because it would be incredibly we're talking about an optical lattice and trapping individual atoms within that lattice. If you don't do that in a vacuum, the air molecules will just cause those ultra cold cesium atoms to bounce out of the lattice. I'm talking about a very specific source right here.
Yeah.
Would you rather I send it to you or share my
you can
screen?
share your screen,
Okay.
but like I'm trying to say, the reason they do it in a vacuum is because they're manipulating the density, the medium, the ratios of the two density. They're not manipulating gravity. So you're begging the question and saying, let's manipulate the density medium ratio, is not manipulating gravity. So you can't claim it to be gravity.
So the density has not changed regardless of the orientation of the
ratio has changed. The ratio has changed because the medium and between the object and the medium around it ratio has changed because you've removed the medium. So once you remove the medium, the density
I don't
ratio.
mean to interrupt, but I don't understand what you're talking about. Density is mass over volume. You have not changed the mass or the volume, so the density is unchanged.
The ratio. Let's, for instance, say it's. How can I put this on? Have you ever seen Sleeping Warriors egg experiment before? You've obviously done this experiment at school where you stick an egg in water, and if you change the density of the water, like to saline water, then it floats. It
Sure.
accelerates upwards. You change the density of the water, so you change the density medium ratio of between the object and the medium. So let's take that water away now. The egg cannot be supported because it's no longer less denser than the medium. So you're changing the ratios between the two, and that's what gives its vector. And that's exactly what I'm saying. When you're sticking anything in a vacuum, you're removing the medium, so you're changing the density ratio between the object and the medium. So in other words, it's not gravity.
A couple of things on that. One, obviously, there is no vector in that case, but
yes, there is.
I just want to clarify that whether or not the vacuum capsule is this orientation or this orientation, none of the relative densities have changed. There is no change in density, regardless of if you tilt it this way or this way.
Remember, the vector is always pushing downwards. You would agree with that? Because the medium,
but I would agree with it because that's gravity.
Because the medium cannot support the object.
But it can't support it up or down, so why just down?
Because you've taken the medium away, the only medium that can support it to keep it up.
But
pressure, because of pressure mediation.
But why doesn't it support it to keep it down? You see, you're just
why? Because you've taken the medium away. When you have a denser medium, this is how the relative density ratios work.
Okay.
When the medium is denser, then it goes up. But because you take the density away, it can only go down because it can't be supported by the medium.
Okay, I'm going to stop sharing my screen here because I was just trying to provide the citation for what I was talking about specifically. But since we're talking about the downward vector here, I just want to make sure, because it sounds like you're just arbitrarily applying the downward vector. If we do a thought experiment real quick, where you have an apple in a vacuum chamber with equal density in every direction, there is no preferential direction in terms of a density gradient. It's equal. It's in a vacuum, so it's the same density above it and below it.
Mm-hmm.
Why does it go down instead of going up?
Because it can't support it.
When you say that it is not supported, why it's not supported up or down? So why does it go down if it's not supported in all directions equally?
Because there's no support. When you
this
is how nature works. You have water on the ground, correct? You don't have water floating in midair because it's denser. That's how the structure works.
Why do you think it goes down instead of up? Gravity explains that. It gives a very good reason why
gravity doesn't. Gravity doesn't explain anything. Gravity just gives a mathematical construct based on more mathematical constructs and wants you to beg the question. Gravity cannot explain the reason why we have things going up and down scientifically, where relative density disequilibrium, you can do actual experimentation proving that there's a vector and a magnitude based on the density ratios.
Again, though, you can't prove that the vector is because of density. Because when you say that it's unsupported below it, it's also unsupported above it. It seems like you're just saying it is a brute fact of nature that the direction of that vector is downwards rather than upwards.
Okay.
Which I don't accept as an explanation. That's just a brute fact.
I can give you another analogy. Law of nature, like entropy.
Mm-hmm.
You would agree that always high to low, hot to cold.
But we can explain that. There's a reason.
Wait. Yes, we can explain that. But can you give the reason why entropy does that?
Yes, I can.
Okay, why does entropy do that?
It's because of statistical mechanics.
False.
If you count
that's mathematical.
Up all the number just let me finish my explanation first, please. If you count up all the different possible microstates of that state, the total number of microstates in which you have very, very ordered arrays versus more spread out, the sheer number statistically is going to trend towards the higher entropy, because there's many more possible states for that system that have higher entropy rather than the number of states that have lower entropy. So it's a basic statistics.
Statistical is only mathematical constructing. It's just a language. Now, you said you can explain why entropy does that. I just did. No, you gave a statistical anomaly on what it could be. I mean, I can give statistics on people betting and winning the lotto. That is not the cause for people winning. That's only statistics based on that. Now,
but hold on, because we're not explaining why people win the lotto. What we're explaining is why only a small number of people win the lotto, and the statistics does explain that in the same way that the statistics explains why entropy increases.
No, again, entropy is not explainable. You can statistically give its behavior based on natural tendencies. That's why it's called a natural law. You don't know why entropy does this. You can't.
But I just explained to you why.
You gave statistics to say it's more likely to happen. That doesn't say why it does it. You understand? Likely to happen and why it happens is two different things. Now the same.
No, it explains why, because of the likelihood.
No, you're not giving the cause.
The cause is it is much more statistically unlikely for entropy to decrease in an isolated system than to increase, which is much more statistically likely.
Okay,
that is the reason.
You would understand mathematics is only a descriptive language. It's not reality. It's not physical.
I agree. The map is not the territory.
So mathematics and statistics is not the cause for entropy.
The reasoning of the mathematics is still the reasoning for the observed results. It's not like I'm saying because these squiggly lines on paper, therefore the results. I'm saying these squiggly lines on paper actually represent what is going on in reality. They are descriptive of reality. If you think about all the different possible states that the system can be in, every single possibility, statistically, the possible microstates that are low entropy are such a small amount of number relative to the total possible states. That is the reason why entropy increases, because of the statistical likelihoods of the possible states. That is the reason why.
Okay, but then I can say, then why can't it just go to the most least likely statistical state then?
It can. That is possible, yes. So it's just very statistically unlikely.
So then statistics doesn't say why entropy, then it's just giving a statistical value based on what could happen, not what is happening.
I would say that is why, but okay, if you disagree that is somehow, for some reason, that explanation doesn't count as an explanation, I don't understand why you disagree with that, but that is the explanation.
Okay, but now let's move it back to relative density, like I'm saying. So when you remove a medium to support it, it will always go down. This is a fact. There's no statistics about it. If you remove the density of the medium, it will go down. This is observed in nature. It's always that if the object is less dense, it will go up. If it has displacement, Archimedes principle, it goes up. Okay,
Sure.
this is observed in nature. We can do science, actual using the scientific method to represent and experiment to show changing the ratios between densities gives either a vector up or down, and it gives a magnitude. Now, when you guys take your object and stick it in a vacuum, you're not doing science based on gravity. You're doing science based on manipulating the medium, so relative density.
Let me just be very clear here. When you're talking about density and buoyancy, you're still talking about gravity, because obviously gravity is still involved there.
No, I'm talking about relative density disequilibrium.
Are you familiar with the free body diagram?
Yeah.
So yeah, it just shows you the object, and it shows every single force that's acting on that object, including pseudo forces. And when you do that, you still have the downward vector of gravity. You just have a larger force upwards from the buoyancy. And the buoyancy, the formula involves gravity in the formula for buoyancy.
Okay. Do you know Archimedes' principle preceded Newtonian 1,900 years? And they used Archimedes' principle without G in it. So how can it be gravity then?
Because Archimedes' principle is not the same thing as measuring the buoyant force.
Archimedes' principle is the buoyant force.
Not quite. I mean, Archimedes'
displacement.
principle is based on the displacement, which is about the weight, which has gravity to it.
No, there's no gravity. Weight is not gravity.
Well, weight is a force that's imparted based on gravity. So
pressure. Yeah. So we can agree then my mouse has a pressure, it has a force on my hand now. It's causing pressure on my hand. Correct?
Well, force is not equal to pressure. There's a difference of units there, but it's, force divided by area.
Okay,
so,
yes, PSI.
Sure, there is both a force and a pressure.
Great, but it has a pressure on my hand.
Sure, and that is imparted by gravity under the basic scientific paradigm.
There's no science for gravity. That's what I'm trying to get you to understand.
Well,
in reality,
that's not true, though.
No, I know it's true. Based in reality, can you give me one scientific hypothesis and experiment for gravity, please?
Yes, absolutely. The detection of gravity waves by LIGO.
That's not scientific hypothesis and experiment. Do you know how a scientific hypothesis and experiment works?
Sure. Oh, you want me to explain? So in an experiment, first of all, you come up with a hypothesis. That's a basic prediction of what results you should observe. And a hypothesis.
Step one. What's step one?
Okay, you want me to go through observation, hypothesis, then you have your experiment after you make your prediction where you have an independent and a dependent variable. You measure the dependent variable, you get your results, and you publish them. There you go. Peer review.
Okay, so we observe a natural phenomena, correct? Where do we observe a natural phenomena for gravity?
Gravitational waves.
What's a gravitational wave? Where do you observe gravitational waves?
There are two independent methods of observing gravitational waves, completely independent from each other. The first one was at 2015 at LIGO, a giant laser interferometer, and the second one was just in June of this last year using a pulsar array.
So, in other words, man-made conjuring up of a apparatus. Is that what you're saying? So, if I can if I can make a time warp machine, does that now make time real?
No, but I'd be very much interested in your time warp machine.
But you understand what I'm saying?
Well, hold on. I'm saying if you did make a time warp machine, then it would support whatever your theoretical framework was in the designing of that time warp machine.
But you see the problem.
If general relativity makes a prediction about what we should see, and then if you want to say it's not an experiment, it's just an observation of gravity, that's fine. I'll accept that. But it's an observation of gravitational waves. If you want an experiment, we can talk about the Cavendish experiment where there's an actual independent and dependent variable if you're more comfortable with that.
Okay. First I'm going to say, you didn't have an observed phenomena for gravity. If you first have to have the observed natural phenomena before you can do a hypothesis to have an experiment.
Gravitational waves would be the observed natural phenomenon.
But you said LIGO, so... you guys had gravity gravitational waves before LIGO, remember?
Yes, they were predicted many decades before LIGO.
So then it was an observed natural phenomena then.
So you're saying that in order to have a hypothesis that makes a prediction, it has to be based on these observations, even though,
it's called natural.
They were predicted mathematically in the framework of general relativity.
Again, so when we present, that's why it comes to pseudoscience. It's just circular reasoning again. If you're going to claim gravitational waves and gravitational lensing or whatever, you have to first get gravity. To make it science, you have to manipulate the independent variable. So that's what I'm asking. You claiming LIGO is now gravitational waves, that's your observed phenomena. Fine. What is your hypothesis for this? How are you going to experiment?
So general relativity was the framework that allowed us to hypothesize a prediction that gravitational waves should be observed if we set up an experiment like LIGO. So there's the hypothesis, the prediction.
But that's not manipulating the independent variable. What's the independent variable?
Well, LIGO was an observatory. So if you want, like I said, if you really want an experiment with an independent and a dependent variable rather than just an observation of gravity, which LIGO is an observation of gravitational waves, if you want an experiment where you have an independent and a dependent variable, then I would point to the Cavendish experiment.
I don't think you want to go to Cavendish because it wasn't an experiment at all.
Well, I can explain to you what the independent and dependent variables were.
That'd be great.
Okay, so the dependent variable in the Cavendish experiment was the torsion force on the wire, which we measured using the torsion wire. That's the dependent variable. What this variable depends on is how close the two masses are. Hold on, I've got a...
So the effect is the torsion.
Let me pull up a little picture for the people listening here. Can you share my screen?
Yeah, so you're saying the effect is the torsion.
Yes, so the dependent variable that was measured is the torsion in the wire here. And then the independent variable is these masses here that are moved closer to the smaller masses, which then are attracted to the bigger masses and spin the whole system clockwise, which imparts torsion on the wire. So the independent variable is how close those two big masses are to the smaller masses, and the dependent variable is the torsion on the wire.
So the independent variable, is it mass or is it distance of mass?
It basically, because in Newton's formula, the gravitational force is dependent on both the mass and the distance. By moving those masses closer, you are effectively increasing the strength of gravity on the free body diagrams of those small m masses. So your independent variable is effectively gravity.
Okay, so no, there's no gravity here. You're just showing torsion twist due to the...
wait, hold on. We're not I said the independent variable was gravity. The dependent video...
So how do you manipulate gravity? So please manipulate gravity for me.
Yes, that is what this experiment is doing.
No, you doing mass and distances. That's not gravity. You said gravity...
That does change the force of gravity.
No, you said gravity is the independent variable, not the mass and the distance.
So... imagine, okay, here we go. You said you know what a free body diagram is. So if we draw a free body diagram for this small m mass, right? You have the gravity that's going downward, and this is just, in the physics consensus. I'm not saying that, you accept that any of these are real. I'm just saying that if you were in a physics class and you were being graded, you would draw a free body diagram for the small m mass. There would be, first of all, there would be the force going down from the Earth's gravity, and there would be another vector of attractive force towards the big M. And as you move that big M from the free body diagram of the small m, the magnitude of that vector increases. Therefore, what you are doing is manipulating the strength, the magnitude of that gravity vector. That is what you are doing.
That's why I'm disagreeing with you. You're already begging the question that it is gravity and gravity is a force. You're already placing... No. This doesn't show gravity. You claiming that gravity is the cause, but you're not manipulating gravity. You're manipulating mass and the distance between the masses.
That does manipulate gravity, though.
What's gravity? How's that manipulating gravity? When it comes to scientific hypothesis, you're supposed to have the IV and the DV. If your IV is gravity, that is supposed to be what you're manipulating. You're not manipulating gravity. So you're not manipulating gravity.
In the Newtonian regime, where gravity is the attractive force between masses, when you move that big M mass closer, what you are doing is increasing the force of attraction between masses, which you are measuring as the dependent variable as a torsion in the wire. That is the IV and dV, and the IV is effectively the magnitude of gravity on that little m.
So mass is the cause, not gravity.
No, sir. You are confusing, like, just the mass, which we're not talking about.
But that's that's the thing you're manipulating. But that's the thing you're manipulating. You're taking a mass and the distance. That is what you're manipulating. That's not gravity. Is a ball of mass gravity?
Mass is not equal to the force of gravity. No.
So, then you're not manipulating gravity. You're taking.
But we haven't changed any of the masses involved.
That's why it's called circular reasoning. This is just begging the question.
Before you go off on that, you agree that we have not changed any of the masses involved here, right? None of the m values are any different before, during, or after the experiment.
And I would disagree and say it's not gravity that causes, it's the density.
How? Like what? The density of what?
These masses are on a torsion bar.
Yes.
They have a weight to them. The density of those weights cannot be supported by the medium around it. So it is forcing itself to seek equilibrium, which would be down. So that's what causes it to swing and have the rotational torsion twist. Let me just be clear.
Usually in the Cavendish experiment, you let it reach equilibrium before introducing the big masses. So it is already at equilibrium. It is motionless, or as motionless as you can possibly get it, hanging there on that wire with just the two little m's. Before you have introduced any of the big m's, it is not moving one way or the other significantly, right? So it is at equilibrium before you introduce the big m's. Now, once you introduce the big m's, how does that change anything about any of the masses or density?
How did you account for any other variables?
Well, there are variations of the Cavendish which are done in a Faraday cage or grounded to account for electrostatics.
And a vacuum.
What other things would you account for?
A vacuum.
It's done. They've done it in a vacuum before. They've done it under lots of different circumstances.
And how great can we get a vacuum with a Cavendish in it? There would still be air pressure inside that system, correct?
Very, very minimal.
And do you understand Bernoulli's principle?
Yeah.
So it would cause a lower pressure between the two masses, which can help cause the air to move through it, which pull the two.
I don't think that follows from Bernoulli's principle.
Yes, a wing, just like Bernoulli's principle, when an aeroplane flies, how the wing is situated, it flies, the lower pressure, which causes it to lift up. It's the same thing.
It's because the aerodynamics of the wing cause the air to move faster above, which decreases the pressure above, which keeps
Bernoulli's
the
principle. So the air, if you got the two masses together and there's air in there, it forces itself through.
But it's in a vacuum.
So there's still air in there. You don't get perfect. You don't get a perfect vacuum.
A few atoms of it.
You don't get a perfect vacuum. What's the best vacuum we got on Earth?
I don't know. Good enough.
10 to the minus 6. 10 to the minus 6 torr. That's the Sandusky, Ohio, and that is not even close to space.
You understand the relative here, right? So if your independent variable is the amount of air molecules, right? You're talking about whatever the best vacuum we can get is versus no vacuum at all. Your independent variable is the amount of air molecules. Are you going to see that big of a difference in the dV of this experiment?
I've seen
manipulating that independent variable.
I've seen the Cavendish done, which the masses go opposite the direction. I've seen the Cavendish where it does absolutely bugger all. And yes, I've seen even electrostatics do cause it to move. Statics causes it to move. The fact of the matter is the masses are denser than the air around it. Now, when you're taking that medium away, it's still going to be having a greater it has less support on it, so it wants to go down more. And because it's torsioned, and if you look at the torsion wire, you would agree it's built with fibers, correct? So it has a rotation to it.
Yeah, but it's already achieved equilibrium.
There's no such thing as achieved equilibrium. It seeks equilibrium, but there's no such thing as equilibrium. It's static.
It's in a potential well.
A static equilibrium. Yeah, but the thing is, if you don't realize, everything you've been saying tonight is, I already believe gravity, so therefore it is gravity. I believe there's a gravitational pull, so therefore it is.
Well,
I mean, you've even
in this
stated
case-
in the beginning that gravity is not a force, so you cannot take this and claim gravity to be doing anything because you're not
I want to be
manipulating
clear.
it.
In this case, right, all other plausible explanations have been debunked. Like, the only known physics, if you want to say it's some unknown physics that's causing this, sure, I guess. But again, of all the known physics, nothing else can accomplish these results other than gravity.
Gravity doesn't exist. Gravity has not even proven. Remember, you're supposed to
But
be
that's
giving.
your claim,
No,
though.
no.
I haven't heard any
You're supposed.
substantiation of that claim.
You're supposed to be giving me a scientific hypothesis and experiment for gravity. You are giving
This
me
is.
no. You are giving me something mass attracting mass, as you put it,
Yep.
and saying it's because of gravity. I want you to show me gravity, not mass attracting mass, because I can give an
Okay.
explanation. You can give an explanation. The
So-
problem is you're not manipulating your independent variable here.
I just showed you the independent variable that's being manipulated.
No,
I don't understand,
mass is
I don't
not
understand
gravity.
Why you, I don't understand your disagreement with my explanation of the independent variable in this experiment.
Because the independent variable is the cause for the effect observed. You are claiming gravity is the cause for the effect.
Yeah.
Okay? So
Yep.
you have to manipulate the cause. You're not manipulating
Yep.
the cause.
So that's what is happening here.
No, you are manipulating the masses and their distance.
That is manipulating gravity.
Again,
Okay, look.
again, is mass gravity?
Obviously not.
So you're not manipulating gravity then. That's my
But we're not
point.
manipulating the masses. We're not changing the masses.
So
of
you don't
anything
change the distances between the masses, how much
involved.
mass...
Is that changing the masses? I'm sorry, but no, it's not. Changing the distances between masses doesn't change any of the masses involved. So it's kind of a straw man to say that I'm saying that gravity equals mass when no, the independent variable that is changing is not mass.
Okay, so
You can
distance,
say,
distance
okay,
is...
distance.
So distance is the independent variable.
Sure. Now here,
So not
what
gravity.
you need to do is think about the free body diagram on that little m. I'm really
I understand what you're saying, but you're not getting... You are manipulating distance. You're not manipulating gravity. Distance is not gravity.
Do you agree that in the hypothesis, manipulating the distance between the masses does manipulate gravity? That is
No.
what our hypothesis is.
No. Your hypothesis is gravity causes mass to attract another mass. That's your hypothesis, correct?
Sure.
Okay. So the independent variable would be gravity, not the mass or the distance.
Well, no. Look.
Then you should say, then your hypothesis should say distance is the cause for mass attracting mass.
Let me just clarify here, right? Our hypothesis is that there's an attractive force between masses that varies with the inverse of the distance. That is the hypothesis. So then, by that hypothesis, I would predict that if we move two masses closer to each other, their attractive force should increase. That is the hypothesis, that is the prediction, and that is what is being tested here.
So still not gravity then.
No, again, the attractive force between objects that varies
But
inversely
gravity-
of their distance,
but again-
that is the hypothesis that is being tested. And we
gravity's-
are manipulating gravity. And again,
No,
that
you're
is the Newtonian regime definition of gravity.
So what is gravity then?
In Newtonian or in Einsteinian regimes? What do you want to know?
There is no such thing as Newtonian gravity. It was superseded 108 years ago.
So I just want to make sure we still use the formulas of Newtonian gravity because they work under certain conditions. If you have a relatively low gravity or a low speed, you can use those equations. So it's a little weird to say Newtonian gravity doesn't exist.
It superseded
If you want to
108.
say,
It
but
superseded 108 years
Einsteinian
ago.
relativity will get you the same results as Newtonian mechanics, but it will do so. It's got much more broad scope. It's more comprehensive. It's more rigorous.
Okay, yeah, like using the tensors and so forth, because
Yeah,
you're trying to.
I'm
Okay,
not equipped to
the
have a whole
metric tensors,
conversation
yeah.
on tensor calculus, but yes, the Einsteinian field equations are much more accurate in much more conditions than Newtonian.
So when you're using the metric tensor, it's just simply taking, let's take a block, for instance, in a fourth dimension, and it's tweaking it in different vectors, you could say.
You mean four-dimensional, not
dimensional.
The fourth dimension.
Fourth dimensional block. I'm just giving you a little thing. But anyway, the point is, it was superseded. And if it's superseded, it means gravity is no longer a force. So therefore, you can't have mass attracting mass, because you require a force for this to happen. We can't observe the fourth dimensional mathematical construct anyway.
We do, but hold on. There's a bit there that I need to discuss. So first of all, just because gravity is a pseudo force in general relativity, that doesn't mean that we cannot measure it as a force. In the same way that we can still measure centripetal and centrifugal forces. You can measure those in an experiment. You can measure them in newtons, the unit of force. You can still measure those forces, just like you can measure the force of attraction between things. That doesn't mean that, just because it's a pseudo force doesn't mean it cannot be measured as a force.
Great. So a pseudo force requires a actual force for it to arise, correct? Like a turntable, for instance. There's an actual force turning that turntable to create the centripetal forces.
I don't know if that's necessarily the case, that a pseudo force always requires a force to exist. I do not know if that is a law of physics.
F equals ma. Force requires a mass to accelerate.
You've already said that you don't want to. You say that Newtonian mechanics is not real. You say so we cannot use F equals ma.
No, I never said that. I never said that. I said we can. We use classical mechanics. It works every day. The problem is when you're placing that G as gravity and saying it is a gravitational force. That's the issue. Because
that is Newtonian mechanics.
No, it was never actually scientifically being validated. It has never been.
But it has, though. Come on.
You still haven't told me what is gravity. You still haven't
I did.
manipulated.
I started this conversation off by telling you what is gravity.
No, you said it's based on a not force. But because of classical mechanics, therefore it is a force, we can count it as a force.
Curvature of spacetime.
Curvature of spacetime is a man-made construct. Space and time are both man-made. Space and time are both man-made concepts. They don't exist.
Well, we can measure the
three-dimensional. We are three-dimensional beings. You cannot observe something in the fourth mathematical dimension.
Again, just to be very clear, we are four-dimensional beings. I don't know why you can't agree that
we're
time
not fourth dimensional. Time is not a thing, it's a concept. We have length, breadth, and width. That's it. We don't have time.
We go through time.
No, what is time?
Time is a dimension.
No, what is time?
Okay,
because this is what we said. This is what I said with McToon.
Let me explain.
What is time?
I'm trying to explain. Okay, so dimensions are how you can stipulate things. If you want to say where I am, right, you would have to give units, right, in three-dimensional space for my location. But you'd also have to give a time for that location, right? Because I could be a different place tomorrow. And if you don't specify the time, then you haven't fully stipulated my location. That is why
reference.
that is what dimensions do functionally. So that is why we are four dimensions, because we exist at a time point.
No, time is a reference datum made by man.
So is space.
No, space is just the absence available probability. It's just available space.
That's not what space is.
That's what space is. If I have a cube of nothing, there's availability in that cube of block. That's what space is.
Well, if you have a cube of nothing, then you don't have any space in there either. Nothing
it's availability.
Means no space, no time.
Space means availability. That's what space means.
No, that is not the case, because
what does
time
space
is
mean?
Also availability. So by your
time
own
is
definition,
not availability.
By your own definition, time is also a dimension, just like space.
No, space is not a dimension. We have length, breadth, and width. Just like you have that cube to say space, that availability, length, breadth, and width. That's it.
Yep.
There's no.
The same with time, though. You have availability in time as well.
No, time is a reference, man-made reference on a timeline, so you can work out certain units.
But space is a man-made reference on a spatial line.
We that's mathematics. Do you understand what it means when you say space availability?
Yeah, things can be available at different points in space. There's potential at different points.
Great.
The same thing applies to time.
So does that make it fourth dimensional, or does that just mean in our three-dimensional reality, if I move into that available space,
Yep.
I've just filled that available space?
That it's the exact same thing with time. Yes.
Great. So we can understand space itself is not physical.
I disagree with that.
Space is physical. So availability, there's nothing there. Something.
No, there's not nothing there. There's space there. Space is not nothing.
It's availability.
No, it is actually not. But you know.
That is, it's availability. That's what space
I'm
is.
sorry, but you will find no citation for this claim of yours that space is availability. I mean, that's a you thing. That's your idea.
Why do they call it space then?
I don't know the etymology of the word space, Flatzoid.
But you just said it's not the reason, so you have to tell me what space is, because you're making a claim now that that's not what space is.
I know 100% that space is not nothing, because nothing is no space, no time, no energy, no matter.
Again, time is a man-made construct. Space is just availability in our three-dimensional reality. That's it.
How much do you understand about Lorentzian transformations in Minkowski four-dimensional Riemannian manifolds? Because that would be how you would go about understanding why space and time are the same manifold.
Those are just based on the line constructs. That's what I'm saying. It's a mathematically based...
The line constructs?
Line. Let's put it this way. If you do a calculus, you're going to have the x and a y. Okay? You're going to put the space on the one, you're going to put the time on the other.
Okay.
Okay, then you're going to do your linear function. You're going to show, okay, it's bending on the y-axis and on the x-axis, and therefore you have space-time bending. It's just mathematical.
So then let's talk about the actual physical observations of space-time bending then, shall we? Gravitational lensing, gravitational redshift, gravity waves.
You haven't proven gravity to be able to make those claims yet.
It doesn't matter though. Let's ignore gravity entirely. Let's say that gravity, we don't know anything about it. Let's just go with the observations. And what we are observing is space-time curvature of space-time. Those are the observations regardless of what we know about gravity.
But we can't do that because time is a man-made construct. It's literally just a reference given by man. Space is just availability in our three-dimensional reality. You want to stick them together and call it fourth-dimensional, which is just mathematical. We can't observe because we're three-dimensional beings. Doesn't make it observable in the fourth dimension.
We do observe gravitational lensing.
We don't.
I hate to break it to you.
You don't.
We do. You want to see pictures of it?
Again, you do not observe what you're claiming. It's just begging the question. How do you prove that is what you observed?
So here you go. With gravitational lensing, the reason why we know that it's due to the curvature of space-time is because we know how optics works. Right? You agree? We understand optics.
Very well. Yeah.
Okay. So using everything we know about optics to explain gravitational lensing only gives you half of the effect. Right? You would predict a strength of the gravitational lensing to be exactly half of what it is. But using general relativity, you precisely predict what the magnitude of gravitational lensing is. And that's verified thousands of times in the sky whenever we look and observe gravitational lensing.
Again, this is just begging the question. You're literally doing circular reasoning. You're saying it is gravity that's causing this. How do you know it's not something else?
Well, again, it could be something else. That's new physics. It would take something that we don't... It would have to be new physics to explain it, because optics and all other known physics do not explain it. But we can predict exactly what the observations are. We can predict it very, very precisely with general relativity. So if you want to say that it's not actually gravity, then you'd have to explain why general relativity works so well, or
but general relativity breaks.
That it's some kind of unknown physics.
But general relativity breaks down when you bring up a three-body, when you stick in a third body of mass.
That is actually a common misconception and not true.
Okay.
It just becomes much more complicated to solve mathematically, but it has been done.
Have you done it before?
No,
Or know anybody
I'm
who's
not
done it
well
before?
versed enough in tensor calculus.
Or know anybody that's done it before?
Personally, no, but we can go and look at the math itself. I mean, it has been done.
Okay, so this is going to get back to my point. So if we get to a person that, let's say, makes a prophecy about something happening in the future, and that happens,
Yeah.
okay?
I am much more liable to believe what they're saying if their prophecies are correct. Absolutely.
Okay. Does now that make it scientific?
Well, if their prophecies are going from a hypothesis to verified observation, and that's repeatable for multiple people.
I can do this with the Bible. This prophecy's been for thousands of years said in the Bible, and it's coming to fruition now. Would you say that's science? Would you say it's scientific?
Well, I disagree that those prophecies are coming true. So
no, they're definitely going. You might need to read your Bible, mate. But anyway, this is not about the Bible. This is all about the point is, if those prophecies are said thousands of years before and they're coming to fruition, does that make it scientific? Because that's exactly what you're claiming with gravity.
If you have a testable, falsifiable prediction that's repeatable and it's proven to be correct, then that is scientific. So if the prophecy is something like, we will observe gravitational lensing at this magnitude, and then we do, then I would say it's scientific.
No, science requires you to manipulate the independent variable. If you can't manipulate the independent variable, I don't
want to get into a whole philosophy of science discussion, but it's a little bit more complicated than just the high school version.
No, the point is, because it's a method, you need to do the method because it's empirical. It takes all your biasness out of the equation. So as soon as you say, as soon as you're making a claim, like we should see this one day. So therefore, if it happens, it happens. Okay, therefore it validates my hypothesis. That's not science. That's just circular reason. That's pseudoscience. I mean, I can sit up and say, okay, every day I wake up, so the sun rises. Therefore, the sun rises because I wake up every day. You see the circular reasoning behind that.
Yeah, but that is a falsifiable prediction that we could then falsify. You could just simply not wake up one day, and then the sun would continue to rise.
Great.
And
so it will be falsifiable.
Yeah, but you would be doing science in that.
Well, I'm going to be manipulating the independent variable, which would be me not getting up. Correct?
Yes.
Great. So when you look at, let's say, for the Sir Eddington observation, did you manipulate the independent variable when you just happened to see it happen?
When you do it multiple times, you are manipulating, you're looking at it, you're repeating the observation multiple times to make sure that it fits among different criteria. So, it's going to happen multiple times. Then whenever it happens in different circumstances, the variables are going to be changing.
So you can give me the hypothesis that was for the gravitational lensing.
Yeah, general relativity.
That's not the hypothesis.
Huh?
General relativity is not a hypothesis.
It predicted the magnitude of the gravitational lensing. That's the prediction.
That's not a hypothesis.
It's a prediction.
A prediction,
which is,
a prediction
science.
Doesn't make it science. A prediction just makes it pseudoscience. To make it scientific, you have to manipulate the independent variable. So with gravitational lensing, how did you manipulate the independent variable?
Again, I don't think that very many philosophers of science would agree with what you're saying.
Science doesn't care about your philosophy.
Well,
science is a method.
Science, Flatzoid?
No, science speaks for itself. It's a method.
It speaks for itself. Is that not a reification fallacy?
No,
what does science say? Are you the science whisperer? Because I would personally say that the experts that are, studying the philosophy of science, I would lend more credence to what they say.
You do know philosophy of science is pseudoscience, correct? Is science objective or subjective?
It's intersubjective.
No.
It's empirical.
Is there
so you match it with reality.
So it's empirical, so it doesn't care about a person's opinions and philosophical
That's not true either.
beliefs.
Science, Science does. You cannot eliminate all biases. I think that's a little bit
No, it
idealistic.
can. Okay, let's for instance take this. Let's try and boil water. You would you would know you require enough heat for that water to boil.
Yeah.
Would that always be the case?
No. You
So-
can do it with pressure as well.
But there's heat generally. When you lower the pressure, you just need less temperature for the water
Well,
to
you
boil.
could boil it in a non-hot situation. I'm just saying it doesn't have to be temperature, but I mean we're getting a little bit.
Yeah, but you just when you put it in a vacuum, you're just making it. You're bringing the temperature, the boiling point of the temperature down. Correct.
Yeah.
So
but
there's
again,
there's still temperature to make it boil. So heat energy. You still require heat energy.
I guess if you want to go
Great.
with that.
So does it care if you don't believe it or not?
No, but again, your biases can come out about in multiple ways in the scientific method. There, you can never completely eliminate biases. But I mean, this is kind of like this is a little bit beside the point.
Science is an empirical method. You know what empirical means?
Sure.
What does empirical mean?
Conforming with reality.
It means there's no opinions or bias to the situation. It's fact, and that's how
again,
it is.
I think that this is very childishly simplistic
It's not.
view.
It's not.
I do
That's
think
science.
So.
But you see, that's that's my issue I got with the globe, because the globe lives on pseudoscience, claiming it to be science. So therefore, anybody that challenges the pseudoscience is seen as a childistic look at science. No, it's not. It's just stating the facts.
Again, I think that's a bit of a straw man of what I said. I said that your idea that we can completely eliminate human biases is childishly simplistic. I wasn't saying that you were childishly simplistic simply because you're disagreeing. I don't want to, I don't want you to think that that's what I was saying. But we are kind of getting off into the weeds here, talking about what is science and
we want to be gravity. Yeah, because we still haven't got to gravity though. That's what I'm trying to figure out.
I have gotten to gravity. I would say like gravitational lensing, gravitational redshift,
That's
and
not
gravity
gravity.
waves demonstrate the curvature of spacetime.
No, that is you begging the question circular reasoning again. I want to know, what is gravity? How did you scientifically validate gravity? You just saying, I looked at the sky, gravitational lensing, therefore gravity.
Okay, so just to let you know how physics is done, right? First, it begins with a theoretical framework. The theory informs us what we can measure. And then we measure it, and if it conforms with our theory, it's reified. If it's not, then it doesn't substantiate our theory, and we have to find a new theory. That's how it's actually done. That's how the sausage is made.
And that's why it's pseudoscience, because it's just circular reading.
Well, it works, though.
Yeah, to a certain extent, but how do you know that is the cause?
If you don't want to call it science, fine. We don't have to call it science, but it works. It makes testable, repeatable, falsifiable predictions that are shown to be accurate.
Yeah.
I don't care if you want to say it doesn't start from a hypothesis or it doesn't start from an observation. It starts from a theoretical framework, and let's go from there.
Science always starts from observed natural phenomena.
I don't care if you call it science or not. I don't care. All I care about is we're starting with a theoretical framework. It's making testable predictions. We test them, and they're accurate. Address that.
I told you. The reason we see mass attracting mass as a thing falling can be scientifically validated due to relative density disequilibrium. You're removing the medium, therefore the object falls.
Again, that doesn't show us why it goes down. That doesn't tell us why the direction.
It does. Because
it doesn't.
Yes, it does. Because that's...
No, you're begging the question now.
No, I'm not. I can okay, hypothesis. Must I give a hypothesis?
Down.
Oh, so when I pick up this and I drop it, that's observed natural phenomena. Correct.
Sure, yes.
Hypothesis. Reason it fell is because the air around it cannot support it. The density ratio.
Support it in any direction, though. You're just assuming down.
Did I pick it up? Did I put energy into the system by picking it up?
Sure.
Great. So it's got
let's
energy.
do an example where you don't pick it up. Let's do an example where it's on ground level.
Okay, so that's the ground level.
Dig a hole,
and
then
goes
you
further.
Don't pick it up. You just push it off. Will it go down?
Yes, because there's no ground
to support it. But you haven't imported
it.
any energy onto it.
Sorry, I pushed it.
Yeah, but that's not imparting up or down energy. You're not imparting energy to go up.
Sorry, this mouse is denser than all the air around it. You would agree? So there's gas hitting around it, everything.
Yep. So it what makes it go in any direction?
So it's not buoyant enough to push it up. The gas
But
cannot
why would
support
buoyancy not make it go left or right or down?
Because this is relative direction. This is how natural tendencies work.
So it's a brute fact. You don't have an explanation for why down.
I'm still talking. So
Okay,
when I drop it and it can't support it, just like your foundation is built from the ground up.
Why?
Do you?
Why doesn't the foundation go from the ceiling down?
Because that's not how reality works. That's just idiotic.
But again, you have no explanation for why reality doesn't work
I do.
that way.
It cannot support the denser weight.
But why can't it support it from going up? Why does it support only below and not above?
Do trees grow from the ground or do trees grow in the air?
Because gravity, they grow from the ground.
No, not because of gravity. Because of germination, the seed comes from the ground. Photosynthesis.
Well, the material comes from the air. Did you know that?
Ooh, and the air is bouncing all around. Did you know that?
Yeah. Because
Right.
the tree takes the CO2, the carbon atoms from the air, and most of the tree is carbon atoms from the air.
So it has energy, photosynthesis. So when an apple grows in an apple tree and that branch breaks and the apple falls, it had
But why doesn't
energy
it
in
fall
its
up?
system.
You have no explanation.
It grew from the ground up.
Uh-huh.
Great.
Yeah. I don't think that you're
So
getting
this is the
yourself
same
out
as
of
what I'm
it.
saying. Entropy is the same. Why don't we get younger? Why do we just get older? It's a natural law, correct?
Is it a natural law that we get older and not younger? Sure, because of time.
Time is a man-made concept to explain the reference.
Not really.
Okay, how old am I?
I don't know.
Great. Does time tell me how old I am?
No, time is not a person to say anything.
What is age? What is age?
It's the amount of time since you were born.
So a reference, a man-made reference to give me an age,
Space is
a
also
time.
spatial
No,
dimensions are also
again,
a reference.
You don't get it. You using a man-made concept to say it makes reality doesn't work that way. Just like entropy is a natural law, it's a tendency.
No, that's what I'm doing. It describes
tendency.
reality.
Yeah, exactly. So when we describing reality with things will fall down because it's denser than the medium below, denser than the medium that cannot support it, that is natural law. It's a tendency
But
always
it's begging the
observed.
question.
No, it's not.
Yes, it is.
Okay, I pick this
Can I
up.
explain
know.
why?
I pick this up. I know it's going to drop because the air cannot support it. This
But
is a fact.
It's begging the question.
How's it
that
begging the question?
Because you're saying that it needs to be supported. And you're begging the question because you're assuming that that support needs to be below rather than above. Why
No.
can't something above it support it? Because
I
the
didn't say that.
downward vector is down. So you are
Natural
presupposing
tendency.
a downward
No.
vector. You are begging the question.
Again, natural observed phenomena. The mouse falls due to the air that cannot support it. This is how it works in nature. We always see it go. When I use a helium balloon, it goes up. How do I know this? Because the air can support the helium balloon. This can be tested, correct?
I agree.
Great. So now when we take something and, like the egg experiment, like I was saying, in normal fresh
I
water.
agree on how density works.
Yeah, great. So density shows true. Medium denser, it has a vector, accelerates the egg up. If
So,
the medium is
you agree.
less dense, that egg will then sink. Correct? So it gives a vector up and down. The relationship between the object and the medium around it gives the vector.
So in a zero gravity environment,
There's no such thing
where
as gravity.
you don't have
Sorry,
any downward
why are you
vector.
talking about zero G? We're not talking about gravity. We're talking about reality. We're talking about
I'm
the
just saying,
density
with
of
your
the
little
object.
density thing, with your little density experiments, they're all ruined in a zero gravity environment.
No, there's no such thing as
They don't
zero
work.
G. What is zero G? What's that got to do with reality? We're busy saying, I observe an object in reality, and I can tell you, based on its density to ratio around the medium, it will always go down because it cannot support it. Now,
So why
I observe
does-
this. Now I can do an experiment to validate this by sticking an egg in.
Yeah, I get your density experiment.
Great.
I'm saying that your density assumes a downward direction on the vector. That is begging the question. But
No, it's not.
if we
It's,
move past that,
I can validate it
it's
with
not the
science.
acceleration. The downward acceleration varies in magnitude based on where you are on the Earth's surface. So how does density explain that one?
We got things called magnetic fields on Earth, don't we?
So now it's not density. Now it's a magnetic field.
Sorry. Why are you strawmanning my argument? You wanted to know why the vector. Now you're
Yep.
asking about the magnitude. Did I say that
Yep.
was the cause of the magnitude?
Well, I asked you why does it vary depending on your location. You said the
And I
magnetic
told
field.
you. So, did I say
So that's your
did I say the
hypothesis.
density was the cause of the magnitude, or did I say the magnetic field was the cause?
So if you're not saying that density is the cause, then why did you bring up density?
The density gives the vector. The magnetic
The density
field,
makes it have a direction?
yes. Didn't you know density
But
gives
why, though?
direction?
We're back to why the downward vector.
Because it cannot support it, so it goes down.
It's circular.
No.
I asked you
I can
why
do-
the direction, and you're saying because there's nothing below it. That is already assuming the direction is down.
Again, experiment. Object in a container of fluid. It is now going
But wait.
to...
You have to start with your hypothesis here.
Okay, I already did it.
But
The
your
hypothesis-
is begging the
the
question.
hypoth-
It's assuming it's circular.
No.
I asked you why down, and you said because there's nothing below it. But there's also
No, I
nothing
said because it
above
cannot
so why not
support
up?
it. I said because it cannot support it.
I get that, but you saying that already begs the question of the downward direction.
Okay, I think I'm going to have to draw this on paint.
That maybe that will clear things up.
Maybe you don't know how a hypothesis works, because to do a hypothesis you have to assume a cause, correct?
Sure.
That's not begging the question.
But again, it's not explaining anything either if you just assume that, like, if I'm asking you to explain why the downward vector, and your cause for that already inherently assumes that the vector is downward, then it's not an explanation. It's begging the question.
Okay, the observed phenomena would be the density ratio of the object relative to the medium. Sorry, let me just... Relative to the medium causes the vector. Correct?
Sure.
Okay. So, what is the IV? The IV...
Wait. That's not your
Density-
observed phenomenon. That's your hypothesis.
Yeah, but I'm just saying we observed it. I'm giving the hypothesis now.
But
We
wait.
observed
We don't
it fall.
observe that it causes the vector.
Observed. I'm going to put this.
So just delete the causes the vector
rock,
part.
rock falls. There we go. Is that what you want?
Okay, yeah, and then change the observed phenomenon to hypothesis.
No, that is hypothesis. Observed phenomenon is part of
I know
hypothesis.
that is your hypothesis. Your hypothesis
Great.
is density rate.
Yes.
Okay.
Great. So the IV... And now to just release this one. So the IV would be the density ratio between the object and medium. You would agree with that?
Sure.
Okay. The dV would be the acceleration either acceleration with a vector
Well,
of
the
as
dv
well.
is vector.
Yeah, the vector. I'm just going to say the vector because it has acceleration. The vector of the object. Now experiment. Oh, I didn't write it. Experiment. Changing the ratio between the object and the medium
Yeah, I get it.
causes
you can manipulate the various
the
density
vector.
ratios, and you can get it to be buoyant or you can get it to go down. I get it.
Okay, now I'm going to quickly draw it for you in very simplistic terms. This is a container with water. This is normal fresh water. And we're going to say, we're going to do an egg just because we got the egg on there. Why not? We're going to put the egg there. The egg is just floating nicely in there.
Yeah, I got you.
Okay. Now.
This is very tedious.
Obviously.
Say.
Okay, but I just have to get because I know some people don't understand this. Okay, then we put it in the same container. Now we just changed the density of the water. So we made it denser now. Okay? Sorry, we've made the water, well, this is the denser, sorry. This would be the salt, this would be fresh water. So the egg would go down, correct? Because it's less dense.
Sure.
So
I mean, I'm not disagreeing with how density works. I just want to make that clear.
Yeah, less dense, more dense. What did we see here? The ratio has changed.
Okay.
So the vector.
I agree.
I
mean, I agree with how density works. I'm not disagreeing with density here.
Great, but I'm telling you, this is simply what we observe in reality, and based on science, we can validate that this is the reason. Now, you asking me specifically, why down and why not up? This is the reason, because the ratio is very specific. If the object is less dense, the vector's up. If the object is more dense, the vector's down.
So let's do it in a vacuum.
In a vacuum, you're taking the medium away. Let's do it in a vacuum. Great.
Yeah, let's do it in a vacuum.
Great.
So that way, the density is the same ratio in every direction.
Great. Is the object, the egg, denser than the nothing around it?
Yeah.
So nothing to support it. So which direction should it go down?
Direction.
So which direct? No. You took
it
dense
is less dense and unsupported in every direction. Please agree with me on that.
So
Come on, we can agree.
No. Listen. What is the hypothesis? If the object to ratio, the density ratio of the object to the medium causes the vector, you took the medium away. The only thing which would make it go up, you took it away. Which direction will it go?
Based on your hypothesis, if it's the difference between the densities that's causing the vector, if the difference between densities is equal in all directions, there will be no vector.
Sorry,
based on your hypothesis.
The egg is denser than the medium around it. Correct?
In every direction, yes.
Sorry. Yeah, if the egg's here, it's denser than every direction around it. Correct?
No. But the difference is in that example, the egg is it's not equal in every direction because you have water in some directions and air in other directions.
Yes, it is. If that egg is in a container and it's in water and there's water all around it, the pressure here and the pressure here is all around it exactly the same. Correct?
Well, no, it's not going to be exactly the same, but...
Really?
Yeah, because of gravity, but...
Gravity doesn't exist.
Okay, well, that's your claim.
No, it's not my claim. I am showing you scientifically you can validate...
That is a claim, I'm sorry, but that is a claim.
Okay, science. There we go.
But I want to get to this vacuum example, right, where it's equal in all directions, so therefore there is no directional vector based on density.
Okay, let's put it this way. Was there air in that vacuum before you took it out?
It depends on your setup, but I'll just say yes.
Great, so let's say this was a helium balloon.
Okay.
And the helium...
I don't know, why do we have to change it from being an egg?
It's going to give you exactly the same results, by the way. The helium balloon is up. It's floating now because there's air in the vacuum. Well, in the container. Now, we remove the air. Which way is the helium balloon going to go if it doesn't explode? If it doesn't explode out, it's going to go down, correct?
But that's because of gravity.
No. What did I manipulate?
Well, again, based on your hypothesis, if the relative density is equal in all directions, then the vector will be directionless. That is a direct result of your hypothesis.
Again, the egg is denser, or the helium balloon is denser than the medium around it. You manipulated the medium. You took the medium away.
Look at what you wrote. Look at what you wrote. You said the density ratio of the object relative to the medium causes the vector.
Yeah.
So, based on that hypothesis, if the density ratio of the object relative to the medium is equal in all directions, then the vector caused by that will be directionless.
Again.
That's a direct result of your hypothesis.
Sorry. There was air in the chamber before you removed it. Do you
what
get
does that
it?
have to do with your hypothesis? You're adding something to your hypothesis.
No. When there was
you didn't
air...
say based on the previous conditions of the medium.
This is reality, mate. When we did this...
Oh, wait, we're not at reality yet. We're at your hypothesis.
Sorry.
And what it predicts.
Sorry. At proxy, the balloon is less denser than the air around it because it's a helium balloon.
I agree.
Great. And what's happening? It's pushing up.
Sure.
Now, we've already got a set reference. Now we are manipulating the medium. We're removing the medium. So we're changing the ratio between the denser... Between the denser helium balloon and the less denser helium balloon and the denser air. When we take the air away, what happens? This becomes the denser. Correct?
Yeah.
Which is the direction for denser? Down.
I don't know. Your hypothesis doesn't say.
Always down.
But you didn't say that in the hypothesis. So again, if you add that to your hypothesis to make it accurate, then in your hypothesis, you are already assuming a downward vector and thus begging the question.
I'm not begging the question. I'm not begging the question because this is observed and shown to be true.
Okay, look, update your hypothesis to say if it's always different, it will always go down. And then you can very easily see that in your hypothesis, you are begging the question of assuming always down.
Okay, let's do this. IV. We're going to change the IV. Is that what you're moaning about?
No, I'm complaining about your hypothesis. I was very clear about my complaint.
The density ratio. It's supposed to say ratio anyway.
Well, you wrote ratio.
Yeah, but anyway.
Every time you meant ratio.
Oh, I didn't even see that.
In the IV as well.
I only see it now. But anyway, ratio of the object relative to the medium causes the vector. So the denser, this should be the density ratio of the object.
Relative
the denser,
to the medium.
we should say the denser object.
Okay.
The denser object relative to the medium will give a vector always of down. How's that sound?
Thank you. Yes.
Okay.
And so there you can see very clearly with your own words that in your hypothesis you are already assuming a downward direction.
Great.
So
and
you are begging the question.
Sorry.
I asked you, the question I asked was why down?
You know why this is not begging the question?
Why?
Because I can scientifically validate this with manipulating the independent variable.
Okay, so I'll ask you the same thing that you asked me. You asked me, how can I be sure that my observed results are from gravity and not from something else? So how can you be sure that your results are from density and not from something else like gravity?
Simple. Because this is observed to happen. I have an actual scientific hypothesis and experiment which always shows true to the observation.
Okay, now I just want you to be honest with this.
Mm-hmm.
Do you think that using gravity we would expect any different results than what you've outlined below. Because we would have a hypothesis as well using gravity, and our predicted results would be the exact same. So you would agree that this experiment is not a differentiating line of evidence. It cannot differentiate between our two hypotheses.
Okay, then I'll ask you to do the same. Would you please do the same as what I just did for gravity?
You mean go through the IV and the DV for the egg?
No, yeah, let's do the same observed phenomena, the egg.
The same experiment, we would have the same predicted outcome.
What's your phenomena? Sorry, what's your hypothesis?
The hypothesis would be this pretty much the ratio between densities, right?
So not gravity then?
No, it is gravity.
No.
Buoyancy already involves gravity.
No. Buoyancy with gravity came 1,900 years after Archimedes.
You honestly expect that the scientific consensus with gravity would predict different outcomes in that experiment you just outlined? Is that what you're honestly telling me?
You're not giving gravity. You're trying to place relative density and call it gravity. So I'm asking you to give your hypothesis for gravity so we can go through the same thing.
Well,
so I can show you it's not gravity.
My hypothesis is that more dense objects relative to their medium fall down. There's my hypothesis.
So relative density then, not gravity.
So we can use gravity to explain that.
Again, your hypothesis is supposed to be to showing the cause, which would be gravity. Mm-hmm. So your hypothesis would be gravity causes.
But you know that I could just say that the buoyant force equals, it's got G.
You haven't got to buoyant force yet. You still haven't got gravity. You are claiming now, we're doing the first step. You saw the object falling. You're making a hypothesis now on why it's falling, and you're calling it gravity. So what is your hypothesis on gravity?
But it's the same experiment, though, right? We're doing the same experiment. One, you use relative density to explain it and can't explain the direction of the downward vector. It starts within your hypothesis already is the downward vector.
It's observed.
In my explanation, the downward vector is due to gravity with the Earth.
So what's gravity then?
Curvature of spacetime.
Again, listen. You are claiming gravity is the cause. So you have to go and give your IV and DV. So you have to manipulate gravity. So how do you manipulate gravity?
Well, gravity changes based on the amount of material under our feet. So if you go to a different location where there's more material beneath your feet, then gravity will be different, and you can measure that.
But who says that's gravity?
Well, that is the prediction of the hypothesis of gravity.
So it's not gravity then, it could be magnetic fields then.
So again, I'll go back to the question that I originally asked you about that experiment.
Or more things under your feet.
How do you know that it's not gravity? Because that's what you asked me, is how do I know that it is?
How do I know? I just gave, how do I know? Because I just stick you through step by step relative density disequilibrium that can be.
And how do you know that those results are not due to gravity?
Because it doesn't show gravity. I can manipulate the independent variable and it will always give the desired results.
Unless you are in a zero gravity environment.
Why are you putting gravity into this? There is no such.
That's what I'm asking, is how you know it's not gravity.
Because there isn't gravity.
And if you repeat the experiment in a low gravity environment, you don't get the same results.
Again, there's no such thing as zero gravity, okay?
Within your reference frame, you can just do that in an airplane.
Great. There's no everything is accelerating at the same rate. That's why you guys call it 0g. But that doesn't.
So then, why doesn't relative density work in that instance?
Because everything is going down at the same rate.
So then, what is your hypothesis broken in that situation? Why doesn't the relative density work in that situation?
Sorry. If I drop a water bottle and I got water in there, I got air in there, and an object. Okay. Mm-hmm. I'm holding it static. There's different impulse forces attributed. Are you frozen?
No, I'm listening.
It looked like you're frozen. Okay, everything has a different force applied to it because everything is different densities. You would agree with that? So different pressures. Different pressures. Water's denser than the air, and the object is, let's say, between the two. So they all have different amounts of force. You would agree with that?
Okay.
Now, when you're dropping that whole water bottle, which vector is all those things falling down at? They all go in the same direction at exactly the same accelerative speed, correct?
Okay.
So the force would cancel itself out.
Okay.
Because they're all moving in the same direction. So that's why you don't see them sorting themselves out in free fall. Note when I gave my
situations where your hypothesis does not apply.
Notice when I gave my hypothesis, it was one object falling, not the whole container with everything else falling together. That would be a different hypothesis. And that
there was no falling in your hypothesis, but okay.
Yeah, well,
your hypothesis was just object to medium. It didn't mention any relative motion.
Well, it would be the same with this. The denser object would always go down because the air cannot support it, the ratio. Helium balloon will go up because the air can support it. It's less denser.
Yeah, this word support, though, is already begging the question. Because the support...
Is my hand supporting this?
Wait, let me elaborate on this. The support, within you saying support, it already implies support below, not above, not to the side. You are already assuming the downward vector when you say support.
Is my hand supporting this mouse?
Yeah.
Okay. If I hold it here, is it going to support it?
No.
No. So is that naturally observed?
Because it's not because of density differences.
In this
situation, the density is the same in both directions. So relative density cannot explain why you need to support it from the bottom and not from the top.
Sorry. What was my hypothesis?
Again, you're just trying to say it's a brute fact.
No. It is brute fact. It's observable. Why
but
would
you can't explain why.
I just did. Denser
your explanation of why is just it's a brute fact.
Denser objects go down.
Why?
Less denser objects
Why? Please. Just why do more dense objects go down? Why down?
Because it cannot be supported.
But why does it need support below it instead of above it?
Because that's...
See how it's circular? You see how it's circular? If you say that they go down because they're not supported, but when you say supported, you're already implying that they need support below because they go down. So it's circular.
Remember when I told you about natural law, natural tendencies to happen? Do we observe foundations in the sky? Do we have foundations on the top of a building or the bottom to hold it up?
But why?
Why? Because that's how nature works. It's called a natural law.
You have no explanation why.
It's called a natural law. Just like you don't have a reason entropy, reason why we get older.
I explained it.
No, statistics is not a reason for entropy.
Okay, but you have to admit at least that I did have something that I would consider an explanation.
I just did give you an explanation.
Is just that's the way it is.
No,
that's the only explanation you have for why down.
My explanation is you can observe this in nature. It's a natural tendency. That's
what I just said.
The reason it goes down is because the air cannot support it.
That's
the reason. No.
That's circular.
Circular reasoning is statistics causes entropy. That's circular.
Not circular.
So
demonstrate to me how that's circular.
I say therefore there's more chances for this to happen, so it happens. That's called circular reasoning, mate.
That's not what I said.
That is what you said.
It wasn't just I say that there's more chances. You can demonstrate this yourself.
So
calculate all the possible microscopes.
Let's do it this way. Hot will always go to cold.
Sure.
Explain to me how. Why that happens? Why it always goes from hot to cold? Why can't it go from cold to hot?
Sum up all the possible microstates of the kinetic energy distributions of those molecules, and it's exactly the same thing I already described to you. It's a statistical likelihood.
So you can't tell me exactly how. You're just saying statistics.
I just did.
Great. So I am saying it can't support it, so therefore it goes down. Why am I wrong? Yours is only mathematical. Sorry. Yours is statistical. Mine is observable. Get it?
Mine's observable as well, but I just want to say yours is not an explanation. Your explanation is just it is the way it is.
Mine is
Right?
observed. Is my
But do
hand
you agree?
supporting it?
Will
Does
you
it
agree or disagree
does
that
it-
I can summarize your position with it? When I ask you why down, your explanation can be summarized as it is the way because
No.
it is.
No. Why
What?
down?
Why is that an inaccurate
Are
way
you
to
trying to
summarize
be
your position?
dishonest here? Why down?
No.
Because the air cannot support the denser object. That's why down.
So why does the air, in order to support the object, why does something need to be below the object in order to support it?
Because that's how we observe things in nature.
Do you see the circularity here?
Okay, I'm going to do this. Statistically, foundations are always built below a building.
Okay.
Do you see now?
No.
I'm doing exactly
I
what
don't.
you did. Statistically, so therefore...
That's not exactly what I did.
Oh, so show me a foundation that's not below the building, please.
So you're saying that because we build foundations below buildings, then that's your explanation for why you need the support below the object. You understand the circularity there?
Is it statistically? Did I give you statistical? It will always be the case.
No, you didn't. You gave me.
Show me one.
you
Show
didn't-
me
you
one.
didn't go
Show
through
me
all
one.
possible
Show me one
scenarios.
foundation. Show me one foundation where the foundation's not at the bottom, please.
Where's the foundation for the International Space Station?
Ooh, nice straw man. I'm talking about a
Oh
building.
no,
not-
that's a building, right? That's a man-made building.
No, that's not. It's in a violation of second law of thermodynamics. But we're not even on that argument.
No,
I'm
no, but
asking
you asked me for an
I'm
example
asking
of
you,
a
show me a
building.
building. No, ISS is not a building. It's in
It's
a
got-
violation
it's
of
got
second law of
rooms in
thermodynamics.
it.
No, listen. Show me a building without a foundation underneath, please. And don't move to your ISS belief with the tin can floating in the second law of thermodynamics violation. Show me a building on Earth that has no foundation, please.
Okay,
underneath.
so now you've moved the goalpost.
No, it's not move the goalpost.
No,
We're
no,
talking
because
about Earth.
before you just
We're
said,
talking
show me
about.
a building, and now you're saying show me a building on Earth.
You wanted to straw man me. Do we live on Earth or do we live in your fantasy space?
Well, we live in the universe. There are people that live in the International
Why are you
Space
being so
Station. They're not
dishonest?
on Earth.
Why are you being so dishonest? I asked, do we live on
That's not
Earth?
dishonest. That's a fact.
Do we live on Earth?
We do, yeah, but not all
Are
humans do.
buildings on Earth?
Yeah, some of them, but not all of them.
The buildings on
I mean,
Earth.
I would consider the International Space Station a building. There's rooms in it.
We're not talking
There's
about
people
your
live
flying
there.
space can. We're not talking about your flying space can. We're
But
talking
no,
about.
we are though. You asked me for examples of buildings, and I consider that within the category of buildings.
Well, I'm not talking about your flying space tin can.
So you're moving the goalpost.
No, I'm talking about a building in reality where we live on the ground.
ISS is a reality, and humans do live
No,
there.
it's not. So, we
You
live.
can look at it. You can see it in the sky when it passes
Dude, you
overhead.
don't believe me. You don't want to go to the second law of thermodynamics because you're going to suffer
We
terribly.
can. Let's go to the second law of thermodynamics.
Okay, how do you get the ISS in the second law of thermodynamics violation?
Repeat your question. How do you get the ISS and what?
In the second law of thermodynamics violation, it violates the law of entropy.
No, it doesn't.
Yes, it does. How does it not?
No, it doesn't.
How does it
Why?
not?
Okay, can you explain why it violates the second law of thermodynamics?
Because it would have to be, you claim it to be in a place that is open to the Earth. So therefore, if Earth was an open system, the gas we breathe would fill the available space, and we would all be dead. You wouldn't be able to pull the ISS
No.
to let it fall.
no.
Yes.
Why do you assume that that all the gas would just leave the Earth? If
Every single
that
gas
doesn't make
law,
sense.
every single gas law in existence.
Well, unless
And
a
demonstration.
unless a force is keeping that gas near the Earth,
Sorry,
such as gravity.
gravity's not a force. Remember?
It's a pseudo force. It can still act with Newton.
Sorry, gravity is not a force. You require a force for pseudo forces to be present. Gravity is not a force. It's a mathematical construct. So again, I tell you.
No, it's not. It's observed.
What's
I mean,
observed?
I've gone through the observations: gravity
No.
waves, gravitational redshift, gravitational lensing, Cavendish experiment. These are all observations. of
Okay,
gravity.
again. You claiming gravity is a force now. That's your
No,
claim.
it's a pseudo force.
So it's not a force.
Pseudo forces can still act upon objects in newtons.
And how did that pseudo force come to rise? To get that pseudo force, you require an actual force. So where's the actual force?
All you require is the curvature of spacetime.
Mathematical constructs don't cause actual forces.
Well, spacetime's not a mathematical construct. Not only a mathematical construct, it is the mathematical construct is describing reality.
Touch
And
space
we
and
can
time for me,
observe-
please.
We can observe space-time curvature in reality, as I already went through with gravitational waves, gravitational redshift, and gravitational lensing. Those are all observations of the curvature of space-time in reality.
Again, time is not physical, it's a man-made concept.
But we disagree on that, and I brought facts to support that.
Space is just a concept to explain availability.
It's not, though.
So I want you to
you're
come
just
and show me.
incorrect about that.
I want you to come and show me time being physical, and
Yeah.
show me space being physical, please.
Yeah, right. Gravitational lensing. Done.
That's not showing me time is physical. That's not showing me space is physical. That is you chanting your religious belief.
Look, it is. Gravitational redshift can show you that time is physical because it shows you that time is dilated based on the strength of the gravitational field. That's what gravitational redshift shows.
Time. Okay, let's do one at a time. Time.
Yeah.
Prove time is physical.
Okay, did you see that paper that I already presented on? I already cited it.
That didn't say time is physical. That didn't prove time was physical.
Oh, it did show that time was physical. I beg
Bring
to
it up
differ
again.
on-
Bring it up again for everybody.
Sure, here you go.
Show me where it's showing time is physical, please.
Sure. So, in this experiment, right, I showed that there was a vacuum capsule. Let's see if there's a picture of their setup here. Yeah. So here's their capsule right here. So this is a vacuum capsule. You can see that there's a lattice right here, a one-dimensional lattice that's vertical. Okay. So over here, these molecular clocks are ticking at a slower rate than the ones above.
So
right?
ticking.
That is showing that time because all of these in their own frames of reference are ticking at the exact same rate, right? That is physics.
So
That
they're
is
physically
derived quantum mechanically.
they're physically ticking.
They're essentially ticking. They're atomic clocks. When I say
Cesium,
ticking,
yeah.
that means that they're like emitting
Frequency, yeah, they
that
get a
we can measure
frequency.
as a tick.
So are you claiming frequency now is time?
That is how seconds are defined. Yes, the definition of a second is
So
a
it's a
certain amount
concept.
of ticks of a cesium atom.
So it's not physical, it's a concept.
No. That is defined physically. The definition of a second is defined physically by cesium atoms. That is the definition of a second. If you look
So
it up.
a cesium atom is time then.
No, it's the frequency of
So
the
frequency.
oscillations of the cesium atom.
Great. So frequency is time.
Basically, yes. So
No,
again,
no,
you can see that each of these have a same frequency when they're arrayed horizontally. They're all ticking at the same rate, but when we shift it vertically, and now they're under a different gravitational potential.
I think you
in a
don't
gradient,
get. I don't think you get.
you can wait. In a gradient, the gravitational potential is different, and so is the ticking of these atomic clocks, thus showing that time is physical.
Time is not physical.
I just showed it.
No, you again are putting yourself into a fantasy, saying, "Look what's happening."
This is real. This is not a
because
fantasy. They really did this.
Because I have change based on the frequency, therefore time.
Yeah, that is exactly what this is showing. Yes, that time is physical.
Time's not physical. Time is literally a
It just showed
reference.
it. I just showed it here.
You got on screen. It's a reference. Is the
No, but
ticking?
they're going the same rate,
Sorry.
right? You agree.
No. Are those tickings at different frequencies?
No.
So they got the same frequency ticks.
When they're in the same gravitational potential, yes.
They got the same frequency ticks. So
according to their own reference frame,
I'm gonna make
each
this.
one
I'm gonna
is-
make this as simple as possible. I'm ticking my hand now.
Yes.
Okay. Is that time or is that my finger ticking?
It is both.
Okay. Now let's say the fourth tick. would you ever be able to go back to that fourth tick?
Nope.
Because time is a concept. It's a reference. It's a unit measure.
Because time is unidirectional.
It's a unit reference measurement. It's not
That's
physical.
not mutually exclusive from being physical.
Stop time for me, please.
I cannot.
Can you forward time for me?
Not really, no.
Can you go back in time for me?
We are going forward through time, but I'm not doing it.
Can you go back in time for me?
I cannot.
So time cannot be manipulated then?
No, I mean, it can be. That's the whole...
No.
Like, that is what special relativity is that time... Like, the difference between time in different reference frames can be manipulated by things such as speed or gravity. That is what relativity describes.
Have you noticed every single argument you've given because gravity?
That's because that's the topic of the debate, yes.
Just stating because gravity doesn't make it gravity. Just stating because gravity, therefore time...
shows that it's gravity.
No. Just because you're stating gravity doesn't make time physical. You haven't...
So then what is it that would be changing the rates of these atomic clocks only when they're aligned in the grain
I don't know.
gravity?
It's not my burden to prove. You making the claim it's gravity, which you...
I'm showing you that it's gravity.
No, you are showing...
This experiment does show that it's gravity.
No, it doesn't.
It does.
No, it doesn't. You haven't even...
It's either gravity or it's entirely new physics. Those are your two options here.
Or maybe you keep on trying to evoke something that's never been proven.
I just showed it right here.
Again, ticking, frequency.
I would encourage everybody to go and read this study for yourself.
Please do.
Here's the name of the study.
It's
right?
like it's
read
like
the study yourself,
it's like the
and you will
Doppler effect.
understand gravity.
It's like the Doppler effect.
Well, it's gravitational redshift, yes.
So with the Doppler effect with sound waves are physical, correct?
Yeah.
Great. Does time be physical? Is time physical?
Does time be physical?
Yeah, that was a
Okay, look,
Is time physical?
Here's the difference, right? Is that in the Doppler effect, what you're talking about, that involves relative motions. But here, there is no relative motion. They are relatively motionless compared to the detector.
But the frequencies change.
Yes, because of gravity.
No, again, you're just making a claim because of gravity.
Fine. Let me refrain to avoid the G word here. The frequencies are changing because of their altitude. Can you agree with that?
So not gravity then.
Gravity would be why.
But notice,
no.
But notice, I'm asking you to prove time to be physical. You take frequency. No, frequency change is not time. The frequency change
is showing that time is passing differently based on their physical location.
It's showing the reference of time changes, not time itself changes. Remember, I asked you specifically, can you stop time?
That just sounds like a distinction without a difference to me.
No, that's what I'm asking.
So explain to me how those are two different things.
I'm trying to explain to you, time specifically is a man-made reference. It's just that it's a timeline with a reference on it. That's why you have your age, because it's a timeline.
Do you think that you might be confusing the map with the territory? You're saying that the map of time is just man-made, but the territory is real. What the man-made construct of time is describing is a real thing.
That's a false equivalence.
Explain why.
Time is only a measurement. It's a reference. So when I say to you, okay, let's have the debate at 9 o'clock, that would be a reference time, correct?
But how is that different? Because you say that the spatial dimensions are real and physical, but those are also still just references based on units that we came up with.
So it's a
concept, how is that different than time?
Man-made concept. Time is not real.
So is space real?
We gave a way to, how can I say, communicate time, quote unquote. We gave a way to communicate so we would not be chaotic. So if someone gives...
But that's what dimensions are. All dimensions are like that, spatial or temporal.
I'm sorry.
That's like kind of what...
I physically have a breadth, a width, and a height. Physically. Time doesn't have anything. Time is literally just a...
There's a difference between you from now and you in 7 years ago. There is a physical difference. So is that time?
Entropy. Yeah. But it's not time.
So
This is why.
I don't know.
That's
It
why they
sounds
have.
like time
That's
to
why they
me,
have
like-
the arrow of time.
yeah.
But that's just explaining.
Well, I will agree with you that
Forwardness.
entropy is important in the arrow of time. There is a relationship there.
Yeah, but
But that doesn't mean that time is not physical.
you still haven't given reason how time can be physical. I'm asking you to manipulate time for me. You're
I
not.
just showed you the experiment that
Wait,
did that.
that didn't manipulate time. That manipulated the frequency. You get it? The frequency of the ticks.
But that we know
which
that
you
it was the
call,
same
wait,
for each.
which you call time. That is not that's not showing time to be physical. That's the frequency of what you call time.
It seems like a distinction without a difference.
No, it's not. It's just simply pointing out to you that you don't understand what physical means.
Look, if we know based on fundamental quantum mechanics, we know based on physics that the frequency of each of these ticks from the atomic clocks is always even, always equal. That's in fact how we define what time even is. The definition of a second involves those atomic clocks.
So
we know that it's always equal based on fundamental physics.
So quantum
And now
mechanics.
if we observe that they're equal when they're in a horizontal plane at equal altitude, but when they're in a vertical plane, now we see differences. Those differences are showing that the actual time is changing physically between all those atomic
No,
clocks.
there's no time changing physically. If I use that cesium clock, yeah, and I use it again, am I getting exactly the same time that I had, or is it further on the timeline when I did the experiment again?
It's the same.
No, you didn't go back in time to do it. You
But
had
it's the same frequency.
It's on the new timeline.
It's the same frequency.
Sorry, did
Not
I do
distinguishable.
did I do it later in the future, or did I do it exactly the same time that I did on the timeline?
You would have done it at different time points.
So then it's a different
you couldn't distinguish
unit.
them.
So it's a different unit of time then.
No.
Yes, because I did one in
No, it's the same
1980.
units of time.
I did something in 1980, and I got 5 ticks
You got the same
per
result.
millisecond or whatever. Did it in 2000, I got the same result, but it was in another year, another time,
Okay.
and I got the same result. Does that
Okay.
tell you it was time that was physically altered, or does it just tell you it's the frequency which you use to explain time?
Yeah, frequency is a proxy for time. When
So
you
it's a
know that the
man-made
frequency
concept.
is always the same.
So it's a man-made concept. It's just like math.
No, that conclusion does not follow logically from the
just like
premises.
math.
But
Just like
hold
math
on.
describes, the frequency describes. It doesn't
Flatzoid,
make it
since
time.
we only have 10 minutes left,
Oh,
I just want
really?
to ask
Can't
you,
believe it.
do you not, yeah, we've been talking almost for 2 hours, right? So I just want to ask you, do you not think that it's like weird or intriguing or interesting in any way that the actual, like, if you don't want to say time, I'll just say the frequency of the atomic clocks changes
Oh
based
yeah, I find
on
it very
the
cool.
height.
I find it actually fascinating.
Do you
The-
have any,
the thing
like,
that just-
I understand that you're hesitant to make a claim about why that is, but do you not think that, like, okay, whenever we use general relativity to calculate what the difference should be, right? Because we can do that. We can predict what the difference in the frequencies should be if the math is correct. And then when we validate it, as was done in this experiment, right? They did it on the millimeter level, like just the difference in the ticking from 1 millimeter to the next millimeter. And they were able to match very, very precisely what they predicted it should be based on general relativity to what they observed. Does that not make you think at all that, hey, maybe there's something going on here?
No, there's definitely something going on, but what you're claiming it to be is the problem. You first have to claim it's gravity to make that claim. That's my point. You first have to make a claim that time is physical. You have to prove it before you claim that is time changing.
So I think that it's okay. So I don't really, I'm not the one that, okay. So I agree that first you claim it's gravity and then you predict what it should be. And if it's accurate, then that supports your initial hypothesis, your initial claim of it being gravity. If your prediction is accurate, it supports your initial claim. That is how science works.
Science works by manipulating the independent variable. You haven't manipulated the independent variable to get gravity to make the claim that it is gravity.
I think that you're just kind of like you're twisting yourself up
I'm
with
more than
semantics
happy.
here.
I'm more than happy to say something's happening there, because there's definitely something happening there. But to claim it is something that is not even proven, that nobody even knows what it is. Nobody knows what gravity is, first of all. So you can't actually claim it's that
What's
if you
the
don't know what
curvature
it
of
is.
space-time?
No. Even
So
that's been
are you talking about like quantum gravity now?
even quantum mechanics is starting. Yes, even quantum mechanics is starting to override general relativity.
Okay, they don't override each other. I disagree
They
with
supersede.
that.
They do.
They don't. But
One
I
was a
just want to
force.
say, like,
One was a force. The other one's not a force. Now they're all
no.
exist
I'm sorry, but no.
simultaneously.
Quantum mechanics does not include gravity. You don't
It takes
include
gravity
in the
away. Yeah,
calculation. Huh?
it actually destroys gravity. Yeah, correct.
It doesn't. I guarantee you. I have completed courses in quantum mechanics. I understand it decently well. I know what I'm talking about here. That it doesn't. They
So
are
things-
mutually exclusive. They don't talk to each other. I agree that we don't know what gravity is on a quantum level. I'm willing to concede
So
that. Obviously,
so you would agree quantum mechanics does then make that gravity doesn't exist then, because it would just
no.
yeah.
I disagree with that conclusion off of it. I just think, basically when you start doing calculations with quantum mechanics at a high enough level, they start failing because you cannot account for gravity. That is it's just not in the theory.
Or if you look at it another way, maybe it's because you want gravity to be real, and because it doesn't pick it up, therefore you don't agree with it.
Basically, quantum mechanics will not predict results on large relativistic scales. It will fail to make accurate predictions because it cannot account for gravity. That is what happens. It's not like quantum mechanics just shows all this accurate picture on large. Sorry, I'm getting a call.
No stress, man.
Basically, it'll fail its predictions on larger scales because it can't incorporate gravity. And the same with general relativity. It will fail on smaller scales because the rules don't play nice on small scales.
They're totally different. Totally different.
I agree. Look, quantum gravity is one of the things I'm most enthusiastic for. I've got my own ideas about it, but they're just ideas. I wouldn't pass them on as truth.
No
but
stress.
I think a very interesting direction that the current physics is heading towards is that space and time are emergent and are not present on fundamental levels. Space and time are only a macroscopic phenomenon.
Yeah, can I ask you one question though? Would you agree with Eric van der Linde? Entropic gravity.
I don't know who that is.
Eric van der Linde, he says that gravity is just entropic.
There is a back and forth about whether or not gravity is an entropic force or not. Leonard Susskind, who's a physicist, would say that gravity is a non-entropic force because basically, like, if you were to imagine like a frozen star and introduce a planet, then you could decrease the entropy in that situation without an expenditure of energy. So then the argument is that gravity is a non-entropic force. But some theories of quantum gravity do have gravity being an entropic force. So there's no consensus about it in current physics.
Yeah. Well, I think it was a great conversation though.
Yeah, this was fun. Yeah.
We do disagree with each other, that's for sure.
I'm trying to figure out where our disagreement even is. It's like we can't agree about the scientific method, I guess, or what. I don't know. I mean, to my mind, if you have a theoretical framework and it makes predictions that are very accurate and numerical, and then when you do the observation and you make the measurement and they agreed with your predictions very precisely, to my mind, that supports your theoretical framework, right? I mean, that makes total 100% sense to me.
Well, like I said, to an extent. But I still see it as circular reasoning, though.
I mean, if it's, I don't know, man. If you think that it's circular reasoning to like make accurate predictions for things that you haven't observed before, right? Because we didn't observe gravitational redshift back when general relativity was conceived. Mm-hmm. So the fact that we didn't have those observations to go off of, but we use our theoretical framework to predict them, mm-hmm. that lends credence to the theoretical framework. I mean, that supports it. That's how science reifies theories.
Well, I think it was an interesting. We agreed to disagree, I would say, but I do agree. Oh. I do appreciate you coming on, and I do say I would love to talk to you again because you are really respectful, and I like that.
Yeah, I mean, I thought that we were able to have a mature conversation, and I don't think that it didn't devolve into anything too rude or whatever. So it was a fun conversation, and like I said, I think gravity is one of the coolest, most interesting fields in physics right now. I'm super interested in quantum gravity myself, so I like talking about these subjects. So yeah, I'd be down to talk about other aspects of gravity or the flat Earth or
Awesome.
whatever.
Yeah,
Yeah,
whenever.
cool.
But I'm going to say again, guys, please do subscribe to Base Theory. Get him to
Thanks,
over a
Flatzoid.
1,000, guys, so he can also start doing streams. Yeah, I really appreciate you coming on, and yeah, we should do this
Oh,
again
and
sometime.
before I go real
Yeah,
quick, I just want to say I am open to debating pretty much most people that are respectful. I'm open to debating on this topic or other topics. You'll see on my channel I debate a whole bunch of different topics. So if you're a flat earther, you want to debate, I'm open to it. Let's set it up. I'm happy to have any debates.